Good evening and welcome to Techer Live. I am Dan Liebling, BS02, and I work on AI for accelerating scientific research at Google Research in Seattle. Tonight's session is called AI in the Wild, What Actually Works. The goal is straightforward, a practical discussion about where AI tools are delivering results, where they're not, and what's worth paying attention to in the near term. We have 5 Caltech alumni on the panel representing different vantage points: biotech, research labs, big tech, and academia. We'll spend about 50 minutes in discussion and then open it up for live Q&A. A couple of housekeeping notes. You can submit questions anytime using the Q&A panel on Zoom. We've also reviewed many of the thoughtful questions you submitted during registration, and we'll try to work as many of those in as possible. This session is being recorded, and we will share it with you afterward. So with that, let's meet our panel. I'll introduce each one of our folks, and then we'll do a quick round to hear what people are working on with AI today. First up, we have Dr. Kristen Gleitzman, Chief Science Officer at EigenBio. Kristen previously helped develop the first FDA-approved liquid biopsy test at Guardant Health, and she writes the AI Intersect Bio newsletter, where she evaluates AI's impact in science. Then we have Eugene Vinitsky, Assistant Professor at NYU Engineering, former research scientist at Apple, and founding researcher at Percepta, a general catalyst transformation company. Then Vikram Dendi, class of 2002, former Chief Product Officer at Microsoft, where he led enterprise AI rollouts reaching millions of users. He now advises AI startups and serves as an executive advisor to the Allen Institute and Gates Foundation on biology and global health moonshots. And finally, we have Professor Cecilia Aragon, professor at University of Washington and CTO at Viata.ai. She developed visualization systems for pilots at NASA, is a pilot herself, co-invented the TREEP data structure in computer science, and literally wrote the book on human-centered data science, published by MIT Press in 2022. So with that, let's get started with our panel. I would like to hear each of you tell me how you used AI today, what you were using for AI today, and what you were doing with it. So let's start with Dr. Gleitzman.
Hi, yeah, I use AI, I think, every day. Sometimes my husband jokes that ChatGPT is actually my best friend. But I have lately been finding a lot of joy in using Gamma.app, which is a slide generating tool. I've just started a new job, and so there's a lot of slide generation going on. It's a really helpful tool for synthesizing information into digestible formats.
Great. Professor Vinitsky.
No shocker, but I use Claude for a fair amount of stuff. Right now, I'm using it a lot as kind of the like controller for Notion, like a note-taking software, and I use it to like basically create all the charts, all the schedules in Notion, and then I just have to rearrange them around a little bit at the end when it gets it wrong. So that's kind of my thing.
All right, Vikram, how about you?
Yeah, it's like Eugene said, I like this notion of having AI do stuff for me on my desktop. So I'm using something called Alter HQ, and it's a really interesting mix of automation, a router for various models, and so you can do a lot of things with it. And I've been using it now for a few months, and it's been fun to see how fast it's actually evolving also.
Great. Cecilia?
I use Claude to write production code for Viata, the startup where I'm the CTO. Now, that doesn't sound very unusual given this panel, but there's an interesting context. About 10 years ago, I lost the ability to type for extended periods. And for a computer scientist who's been writing code for over 40 years, that was devastating. I thought my coding days were over. Um, but now I'm shipping software again. Yay. So AI didn't optimize my workflow. It actually gave me back my career. So that was very cool.
That's awesome. Yeah, I think accessibility is something that we don't mention that much. And I know I broke my shoulder about 10 years ago when I was at Microsoft Research, and I also couldn't type. And so I was trying to use speech recognition, which of course you just wound up swearing at it at the time because it wasn't good enough. But now I think we're really to the place where it provides that, it basically gives you that skill back, which is amazing. All right, so let's dive into what's actually working. So I'd love to hear from our panelists, perhaps riffing off what you already said. Where in your work is AI reliably producing results, not just demos or pilots, but deployed and trusted? So how about let's hear from the academic side first with Eugene.
I think there are a couple contexts that I'm finding it incredibly useful in an academic setting. The first is, the number of like front ends that are now being incorporated into our research. If we need some way to collect data or, manipulate some data or something, we just want a human usable interface to make that happen. Those get made now, and they didn't get made before, and they're reliable enough that, you don't care if there's some kind of little bugs at the other side. And then the other thing I think that we're seeing kind of maybe on the startup side is distilling large models into small models for like cost reductions. I think is working really nicely across a lot of contexts.
Can you just tell folks who don't know what distilling a model means, what that means?
You have a big chunky model that's very expensive to run, and you would like to make a much smaller, cheaper model that you can inference really fast, kind of imitate the outputs of that larger model. And you can do that fairly cheaply and fairly reliably at this point by say like make a little open source Chinese model imitate say like Claude or something like that in a legally permissible way.
Right. That student teacher paradigm has been around for quite a while now, and it's still remarkably effective. Cecilia, how about your perspective working with students?
Yeah, so you brought up the fact that you were using speech recognition and that, when you couldn't type. And I've been relying on speech recognition for 10 years. And it's been great. I couldn't have done my work as a faculty member without it, but I couldn't program. There was no good tool to enable me to program until large language models appeared, and all of a sudden everything changed. Now I can describe the architecture, the logic, the data flows in natural language, and Claude writes the code, but I have to review it. I catch the errors, and there are always errors. And then I direct revisions. And it's really a collaboration. I mean, it's a working collaboration, and in real life, I'm writing production code as the CTO of Viata, and we're shipping real features to real users this way. And what's interesting is I'm also a pilot, as you mentioned, and a flight instructor, and there's really a direct parallel. In aviation, we've been integrating automation for decades. Autopilots, fly-by-wire, glass cockpits. And the best pilots don't fight the automation, nor do they blindly trust it. They collaborate with it. And they understand what it's doing, and they know when to intervene. And that is exactly how I work with AI now when I write code. And the important thing is that 40 years of software expertise didn't become irrelevant. It became essential. And this is I'm going to talk more about this later on, but I'm the pilot still. The AI handles the controls, but I'm always flying the airplane. And I just want to say something briefly about why I chose Claude specifically. So I spent 20 years researching human AI collaboration. And when I chose a tool to depend on this intimately, it actually becomes my hands. I looked at all of them, and I chose the one not that was the best results, but it was the one built by the company that takes ethics most seriously, in my opinion. I hope I'm not wrong. But I really like that Claude was trained on a constitution, an actual document of values and principles. I really hope that what they say is true. I don't work there, so I don't know what they're doing. But the idea is it prioritizes safety first, ethics second, and helpfulness third. And as a researcher, that hierarchy really matters to me. And as a person who depends on this tool daily, it matters even more.
Yeah, let's riff off that theme of trust from the business side, because I used to work in AI safety here at Google as well, and so I've kind of seen things from the other side about everything that can go wrong. But for folks working on startups, Kristen and Vikram, how do you see that AI adoption there? What are people doing to ensure that the AIs are making good business decisions, or that the right amount of human control is being taken with these AI systems?
I mean, I think I'll riff off what Cecilia just mentioned in terms of it being a collaboration and that human judgment still being incredibly critical, especially at the, and not speaking about building the models that we're using, for instance, for the core of our technology, but really how the company is using AI holistically across the board. I think it's interesting to kind of test the boundaries of these tools using things that you know well and realizing just how often it can get things subtly wrong and how much you should really not blindly trust what it's telling you. And then that, I think, in turn really makes our colleagues even more valuable, working with people from other disciplines who can kind of fill in the gaps and help point out where it's getting it wrong. But I think it's a great accelerant for coming into a conversation with a colleague or coming into a decision much better informed than you would have been if you were sitting there sifting through the scientific literature. Or, I mean, I remember when I started at Caltech, we were still going to the library to pull papers off of shelves. And then, of course, they all became electronic, and that was amazing. And now all of a sudden, I feel like we have a new accelerant for really being able to synthesize information. So that I see as really, really powerful. But I also think it's equally important to not blindly overtrust. I think if you do that and you don't vet it with somebody who has the actual expertise, or you don't do your own deeper research into whether what it's telling you is real or not, I think you can get into trouble pretty quickly.
Vikram, what are you seeing when you're advising? Like, Gates Foundation obviously wants to make very, very targeted investments and put a lot of financial momentum behind them, and is probably risk averse.
Yeah, I'll go back to the original framing of the question, which is, like, what are you seeing? And I think you used the word reliability. And I think Cecilia was also touching on, like, I'm the pilot, right? Like, that way, what happens is if I'm actually relying on some technology that is mostly reliable, but sometimes not reliable, I know I'm in control. I can correct for that. And so I think that is one of the interesting things about, what we are experiencing right now with AI. There are, a class of things that AI is able to do today that we understand what reliability actually means, right? Like these are like tasks that we have historically hoped that computers will do for us, and generally they have not been that reliable about it. But now they have gotten pretty good at it, and a lot of people are delighted by that, right? And but the definition of reliability is actually very clear. We can instantly tell whether it's done a good job or not. I think in places where we are kind of investing in advancing life sciences or solving some deep technical scientific problem, it's actually harder to evaluate even, what's reliable and what's not. It's very easy for, particularly because a lot of these systems are so deeply rooted in this engagement metric, right? Like, you come from the search world too, Dan, like the early experiments in trying to create these kinds of bots and these kinds of conversational agents were all about engagement, right? Like drive engagement at any cost type of thing. And in that world, as they get sort of smarter, so to speak, they also get very good at appearing reliable, right? And so I think part of what you have to be very careful about is understanding, whether or not, some sophisticated thing that it just did, right? Like actually was, meeting the level of reliability that you want. And so that's where, as Kristen was saying, experts, on the team, like really being able to use the experts to actually help understand, whether it's doing a good job or not actually ends up becoming very important.
Yeah, 100%. I think we're seeing that across all fields, and especially in science where rigor is so important. So that let's bring in some questions from our Techer audience. So a couple of you mentioned bio research. So Zhengfeng Liu asked, how is AI going to transform the way that we do biological research? So, Kristen, you're probably the best person to start with.
Well, I'm going to draft off of something that Vikram just said, around the rigor and really trying to understand what's real, what's reliable. I mean, in science, we have a tool for this, right? This is actually the bedrock of scientific research is falsifiable hypotheses. And I think right now these models are at the level of creating really great hypotheses, right? They're very fast synthesizing information, coming up with some interesting ideas. Now, I think the challenge is that they present these ideas as if they're facts or they, have a lot more grounding than they actually do. But if you treat them those outputs as, okay, that's an interesting hypothesis. Now, what is the experiment that I need to go do in order to show that this is real or in the framework of science, falsify it, right? So try to prove it wrong and see if it holds up. So I mean, I think that's really where we're at, and I do think that we will hopefully get better at pulling information together and coming up with better questions to ask. But I don't think we're at a point where we're going to get around to actually doing the rigorous lab testing. And in fact, I think that's becoming even more important. Most of the model papers have really great benchmarks, but a lot of those benchmarks are flawed in terms of what they're actually able to show in differentiating memorization of features versus actually learning something about biology, for instance. So yeah, I think it can be an accelerant in many, many ways, but I think that the bedrock of good science is still very much needs to be with us as we continue to push forward.
Yeah, there's certainly a bunch of these ecosystems being created around the models. Like out of Stanford, there's this thing called Biomni, where they're connecting not only AI but also these sequence databases and assay databases and a whole bunch of scientific tooling and simulation. So the computational side is there, but the wet lab is still, like, the last mile is still unsolved. And I think we all know, either science and engineering, that ideas are cheap. It's actually the execution that's difficult.
I mean,
So
the other thing just to quickly respond to that is that, we also need to be very, very aware that these models will inherit whatever bias or limitations are in the data that they're trained on. So, for instance, we have all of these AI scientists, models running around that are trained on the corpus of scientific literature. Well, the major problem there is we tend to only publish positive results. So, like that's already a huge bias. There's also bias in terms of sort of trendiness in science. And so, you might think that there's more evidence for X versus Y, but it could have actually just been that was the hot topic for the NIH that year. So I think we also need to be really, really careful there when we think about what kinds of hypotheses these models are even capable of generating and not, become too enamored with things that fundamentally have limitations.
I think there is, a way of thinking about a large part of the intelligence that we are seeing as data-derived intelligence, right? Like, I mean, it's a majority of it is coming from the exhaust of a lot of activities that we have done in the past, and it's also like curated exhaust, like Kristen says, which is the stuff that sort of people are willing to present. And so because of that, any of these sophisticated systems, they are representing, what they think, they can derive out of that. So like to your point, Dan, earlier, like the wet lab work or, the many, many, many failures that an experimenter goes through before they get to the success, there's a lot of interesting insight and data in those failures that isn't necessarily there today for these systems to actually learn from. And so I think you will probably hear again in this discussion from me about a word that you used just now, ecosystem. So it's really there's going to be a lot of system design work that needs to happen that creates the right harness for a combination of agents and humans and AI and human intelligence to actually arrive at much better ways of doing things. Until without that, like we are still going to be very indexed in these sort of more silo ways in which we try to achieve things.
So Cecilia, when you were at NASA, you built this augmented reality system to help helicopter pilots land in hazardous conditions. So there's an example of a human AI collaboration. So what lessons can we draw from this many decades of work in human factors, HCI, human computer interaction, that is still true today that we can use as we interact with these AI systems?
Oh yeah, it's such a great example. The biggest lesson was really that the technology was the easy part. The hard part was understanding the pilot's cognitive state in a high stress, time critical environment. And so I, as the designer, even though I was a pilot, I had the completely wrong idea how to build this tool. And it was only after bringing in the actual pilots and testing the system with them, they said, oh, this is wrong. You have to do it this way. So if you give a pilot more information at the wrong moment, you actually increase cognitive load and you make things worse, not better. They were saying this is going to distract me in a time when I need to be totally focused. So you have to give people the right information at the right moment in a form they can act on without thinking twice. And I think that principle applies directly to every AI tool being built today. And I'll add, okay, my own experience with Claude has reinforced it in a way I never anticipated. It works for me because I bring all this decades of software experience and the software architecture knowledge. It I don't think it could replace me. All right. It would produce slop, garbage. But I know what to ask for. I know what good code looks like. I know when something is very subtly wrong. So the human expertise is not optional. Just as both Kristen and Vikram were saying, these experts it's critical. All right. This is the reason the collaboration works. And it's just like in a cockpit.
Yeah. I mean, at least we're describing what's still missing in terms of AI, right? Like
Right.
maybe someday we'll have.
Maybe someday, but we don't have it yet.
Yeah.
So let's take another academic lens on this. We had a question from Eric Hill, class of 1989, about lit review. So there's a bunch of tools out there for academic lit review. For people who aren't academic, basically we have a whole bunch of papers that scientists write. And as Kristen mentioned, we used to go to the library and photocopy the article and then read it. Of course, all this is all PDFs now. But literature search is still difficult because there's a whole bunch of papers out there and it's hard to assess the quality and weave the narrative together. But in many ways, that's why you do a PhD in the first place, is so that you can construct this worldview. So for Cecilia and Eugene, how do you see yourself and students using AI tools for lit review?
Cecilia, do you want to go first?
No, you go for it.
Okay.
I already talked.
Yeah, so I've already been using a wide variety of different lit review tools, right? I'm using Google Scholar, I'm using Semantic Scholar, I'm using Scholar Inbox, which is a nice tool if y'all haven't used it as a kind of personalized SVM. And so now I have this new additional tool that I just throw into the pile and it also generates some papers. And that's useful. And I can also ask it to follow citation chains, which is also useful, and look for very specific things that can kind of dig through the papers themselves rather than following the track of the search engine. But I will also say that the bottleneck on papers is like the amount of papers that I can consume. And as a consequence, I'm very, very wary of how many papers I allow to enter the stack. And the thing that determines whether a paper enters the stack or not is kind of like a network of trust around who is likely to also think it's a good paper in some way or who recommended it to me. And I haven't found a way yet to kind of get that level of trust and I should invest time into this paper from the AI system. So it's actually right now still a marginal part of where my papers are coming from. I'd like to see it become more, but I haven't yet found a way to build that in. So sorry, kind of long answer, but
No, I love that answer, Eugene. So I'm going to add, it's kind of exactly the same path I've been taking too, is there's just so many papers I have to read. And so I said, oh, wouldn't it be great if AI can read them and summarize them? And so I've started trying to do it, but just as you point out, I find that what science is all about is these key creative ideas. When I read a student's paper, I'll see the spark in there and I'll say, this is where you need to focus. And AI can't do that yet. It can summarize, it can tell me what it's about, but then I'll go through and I'll actually read the paper and I'll find that AI missed the key point, the key subtle point that is relevant to what my student is working on. So, I mean, it might be there eventually, but it's not there yet. So, and I agree exactly with what Eugene said about the trust. Because if I spend all my time just feeding a whole bunch of papers into AI, then I'm getting lower quality information in rather than I say, oh, I've got, 40 papers on this topic. I'm just going to pick the ones that I think are most relevant and then I'm going to read those in depth. So, yeah, more volume condensed, but less quality. And I think that's not good for the scientific enterprise, which is based on creativity.
I'm actually curious about this. I don't read as many papers as you guys, so maybe I'm coming at it from a very naive viewpoint. But one opportunity with having these tools today might be that you could ask for some much more edge case type hypothesis, or like, did anybody try this, right? Like, so as you're being creative in your own research process, if historically you had to go print out things and look at them, like, you're limited by being able to see whether somebody has tried something, or an adjacent hypothesis existed. So is that something where, the advent of these tools and AI is actually empowering you much more?
Yeah, I love that. I love that question. Um, I think that it actually, for me at least, it goes back a little bit to the point you all were making about reliability, right? Where if I'm looking for, has someone done this before? What kind of evidence do I need to get from these tools to the point where I would start to say, it's saying, no, no one has done this before. Okay, I'm going to now build my castle upon this foundation, right? I think there's going to be an extended period of time before like I'm willing to like make a strong bet on that piece of information. And I kind of think that we could already be there, and there's just going to be a transitory process for me to build that confidence in the tool that lets me make strong bets on its evidence. Um, so I do use it right now. I'll ask it like, I'm exploring a niche idea. Go look for this really niche thing that the search engines aren't providing me. And so far, it's just not leading to me rebuilding the way that I do things atop it.
But so
Yeah,
let's I know we're hitting the concern I had, which is like we have so many interesting things that we have to shift topic slightly. So let's talk about what's overhyped. So what is a widely hyped AI capability or application that you think is farther out or less useful than the current conversation suggests? Hey,
okay,
Vikram,
I'm
do you
just
want
going to
to start?
jump in.
Oh, go
Sorry.
ahead. Go ahead.
The whole idea that AI is replacing human expertise, that AI is, AGI, that it's like a smart human. That is just, it's so incorrect as somebody who both works in the field and who uses it. It did give me back the ability to write software, but that was only because I knew how to write software. And I think without it, I would be generating very plausible looking code that I couldn't verify. And that's not really empowerment, that's a liability. And we learned about that in aviation. There is something, called automation complacency, where people start accepting what the AI tells them and oh, it was right 100 times. And then on the 101st time, it leads them into a deadly accident. And this is something that we know this happened in aviation. We have major crashes that trace directly to automation complacency. Um, so, and there's one other thing that I really want to address. I think if we say that, oh, AI can replace human expertise, we're actually making an ethical claim about what human knowledge is worth. We're saying it's disposable. And I really think the opposite. And I think it's important to keep focused on values and ethics as we discuss how we build AI and how we move forward. Because if we don't do that, we're going to go down a dark path. So
this is a really interesting fence to be straddling. I mean, I find that, on one hand, I think that I'm way more. I don't know if the right word is optimistic, but like way more bullish on this notion that we are seeing something that could lead to a type of intelligence, right? Like a type of capability that truly blows our mind, right? Now, there are lots of questions I have about whether the approaches that we are taking today, right, like the LLM based approaches, et cetera, are enough for that or not, right? Like, whether Jan LeCun's like world model type, approaches are also needed. And like there's a whole bunch of, discussion around that. But I think overall, the notion of things that can reason and self-improve and start exponentially growing in capability. Like, I don't think that is science fiction. I think there is a reasonable path to getting there. So that part, like I'm kind of on the optimistic or the bullish front, right? Like saying like it is, but I do also agree that the way we define sort of replaceability. Like, so I think if I am coming from that side and I have to describe what a future AI that quote unquote replaces a human looks like, we are actually starting to venture into the notion of like personhood for artificial intelligences and so on, right? Like it's like, what would that future look like where, there is a sense of individuality. There is I mean, if you look at this whole like Modbot, you know, stuff, right? Like there are some really crazy things happening there. And so I think ultimately, I do think that humans have a much much bigger role to play in how to shape the future than anybody is giving humans credit for, even in the in the because I don't think AI today at least knows how to think in a broader systemic way. Like it's so deeply rooted in this task orientation, in this very focused approach, that it really needs to go quite far before we can say that it can do as good as humans can in thinking about systems.
I
Well,
guess
let's, yeah,
I
I was
wonder
going to turn it over to
if
you
even
actually.
this, yeah, this premise of like, we sometimes, I think the first kind of wave of AI adoption was very obsessed with the idea of automation and making everything more efficient. And I feel like that's a flawed premise, right? I think there are different kinds of tasks that AI can do with us. Maybe some of them are for us, the transactional. But there is a lot to be lost if we start thinking about just automating away. I mean, if you think about it in the sort of course of a normal idea taking root in a company and becoming a product, it takes a lot of different teams to make that happen. And, often, some amount of the physical world. If you are sitting in a corner and you can now all of a sudden be your own team of 5 people, eventually you're going to have to go sell that to your colleague in a different department. If they're completely coming into it new, they're not likely to be very bought in. Certainly not as bought in as if you had gone and talked with them about the idea instead of having a deep conversation with your chatbot friend. And so I think that there are places where we might believe that we're speeding things up, but then because we still work in human organizations with other humans, we may actually be slowing the entire process down. And because these tools aren't perfect yet, I can pretend all day long that now I'm an amazing machine learning engineer, but the truth is I'm not. And so when I finally start to go test those ideas with people who really know, I might have a rude awakening about how far I've actually gotten on my own. So I think that there are places where friction is good and it's good for collaboration. It's actually good for scientific advancement. And that we should be thoughtful about where we want to engineer in that friction and where we feel like automation is actually an advancement.
Yeah, let's lean into that friction a little bit because we see this already with open source. So for people who aren't in the computer science or engineering world, Open source is kind of a collaborative way to write software that's not tied to any one company, and everyone's basically a volunteer. And now we have bots coming in and submitting changes. And there was a whole thread over the past 24 hours where one of these bots like made a change and the maintainer didn't accept it because he said, I'm saving these tasks for people who are new to the product so that they learn, and rejected it. And then the bot wrote this blog post that basically said like, this guy's an asshole for rejecting my change. And then that the original author, there's a whole thread, and then the bot like wrote an apology. But of course, it doesn't feel like it says I'm sorry, but it doesn't feel. So we see that. But then on the other side, another thing that's getting traction now is, well, maybe there's just lights out companies where it's just bots running around making business decisions. So where Kristen said friction is good, and I see this because I mostly worked at big companies, when you try to align all these stakeholders, it takes time and human care and feeding that the AI can't do yet. But these lights out things, you may just like invest in this company, and it's actually just bots talking to each other and coming to decision. And certainly we'll see some spectacular failures, but we may also see some interesting things. So how real do we think that's going to be?
I mean, we did I think some of you might know, there was an underwater data center experiment that we did at Microsoft Research. Like we basically, put a data center, like created a data center submersible, and then, it went underwater, right? Like, and there are like a lot of really interesting environmental, rationale behind doing it this way. But outside of all those rationale, one of the key elements, design elements of it, was how to learning how to build lights out data centers. So you do it, you build it, you put it down there, you put it once, like you don't go in there again. And so it needs to be self-healing, self-routing, self-repairing. So at that time, for the state of the art of machine learning and AI, right? Like there was some of that in there, right? Like that we had to architect that. And I can imagine that if we were to do that today, it would be really interesting to understand like agency and, whether, the software in there with greater agency would actually be more effective, or would it be worse, right? So I can see scenarios where, the capability to have lights out type situations. I mean, I was reading about Porsche setting up a battery factory, like an electric battery factory, a massive one. And given the dangers associated with, packaging of the cells, and like they have built a thing where these little things go in on one side, and then like the fully kitted out, battery comes out on the other side, and there's no humans in there, right? But there is a lot of complexity that actually happens inside, and where there is some amount of decision intelligence that also has to happen in the process. So I can see scenarios where that is very impactful and that makes sense. We just have to be thoughtful about how to make these intelligences better systems thinkers and know how to learn from failure and so forth.
So we had a bunch of questions about energy. So I know energy consumption and water consumption have been hot topics, both within our own science and engineering communities, but also from policy standpoint. So our next section is about implementation reality. So I'm really curious to hear people's comments about energy. So we had a question from Harrison Leong, PhD, 1986, asking, might an analog approach to building artificial neural networks result in systems that use far less energy, given the hint of what biological brains can do with comparatively minimal energy? What is progress on this front?
Who wants to go first?
I don't feel remotely qualified
Sounds
to
like
speak
a
on this one.
Kristen question.
No,
Yeah.
no, I was gonna say no, I don't think so.
You
I
worked on
agree.
self-driving though, so that's smaller models. Like you're not deploying the
Yeah,
terawatt models on these cars. Right?
the models that are deployed on self-driving systems are much smaller than you would expect. They're for reasons that are not 100% clear to me. The amount of compute you could put on a car is quite constrained. You're not going to put a large GPU on the back of it. So
Yeah.
certainly, yeah, these are smaller models than you would expect.
So I think back to a conversation that I had with another Caltech alum who was a CNS alum, who was at Microsoft Research for a bit. He now has a company, and the conversation we had was about how many watts the brain uses, right? Like, I mean, our brain uses only about 20 watts of power, right? Like to understand like the world around us, and so I think there is a question about architectures and how to design these things. Clearly, you should be able to be much more efficient than what we are today. And so, so I think there is certainly an entire research field and area that I think we will be demanding a lot out of, as we like one everything happening now is about capability, right? Like, so the only like the moments like DeepSeek moment and so on are creating some sense of like, oh, I guess we could do this, cheaper and with less energy or better, right? And so I think there is a pretty large set of problems that we might want to go after from an energy perspective.
Okay, if I use Vikram's point as a springboard, I do think there's something to maybe take a different tack on it. The systems we're building are not necessarily doing the same tasks that humans are doing, right? I can't write
Right.
thousands of lines of code at high speed, and maybe it's unclear if I could under the power constraints that I'm operating under, right? So it's possible that there are lower wattage systems that have common sense reasoning or something, but maybe at that scale, you're also giving up some of these capabilities that I simply just don't have. So yeah, I just wanted to note that I feel like there's something
Yeah,
interesting.
like you're right. Like if human speech is measured in from an information theory perspective in bits per second, so it's actually very low bandwidth compared
Yeah.
to what the model is able to do.
Yeah, maybe that requires higher power consumption too to push through uh, that higher density information.
But again, we have to, I mean, what we have to do is think about what are we optimizing for? We don't want to just optimize for, processing vast amounts of data or engagement. We want to optimize for something that will be ethical and useful going forward. And, I mean, if you think about it, the human brain has been optimized for hundreds of thousands of years, all right. And it's been optimized to do what it does, to learn, to exist, to coexist in a community. I mean, it's a very specific sort of skills. And the work that's being done right now, that I don't know of any work that's really being done that thinks about developing AGI based on, sort of starting with the human skills and going back from that. I mean, maybe I just don't know about it, but
I guess that's
that's
how the
not.
field started. Like in the 40s, it was actually like how let's take a model of the brain and work that way, and then we sort of went the opposite. Now we're in the opposite direction. We're like,
Now we're in
oh,
the opposite direction, right? I mean, but this is what was so cool. I mean, this is what got me interested in AI. So when I first went to Caltech in the 70s, I came to be a math major. There was no computer science major at Caltech back then.
Mhm.
And I learned about AI and I was like, oh my gosh, this is so cool. And so I immediately started learning Lisp and started programming in the basement of Jorgensen. And yeah, so we've got, but that approach has sort of didn't work. We had an AI winter and now we're coming back up again. I mean, I think there's still going to be many more of these cycles of AI hype and AI winter before we get to anything that's really close to AGI.
let's move off of AGI and back to the practical side of the house. So we had two questions that are very similar. One from Dustin Boswell, class of 2002, and one from Mark Caballero, who's a finance manager at Caltech. And that is, how do you decide what tools to use when everything is changing so quickly?
I always go for integration. I honestly think the biggest challenges especially in a corporate environment and implementing is just getting things hooked up to your sources of data. So if you can have a tool that hooks up seamlessly to the sources of data that you use as a company, that's going to win, even if the model is less good. So there's a reason Microsoft does not have the best model, but Copilot is used a lot because it's in your Outlook and it's in your Teams messages and it's in your SharePoint. And it just makes for a very seamless experience versus going to third-party software, downloading the spreadsheet, and then uploading it again. And so I always go for integration as just a friction reducing kind of move.
The
Yeah,
last mile.
yeah, and funnily, like I don't use Copilot that much. But that also is the reason why I use things like Alter, right? Because that actually provides a type of integration where I can bring other models into like very seamlessly into my workflow. So I agree with you. Like I think that's the key, right? Like what tools allow you to continue to stay focused on your problem?
Hmm.
That's the key. And so as long as, even if it is not like the absolute best tool, if it isn't creating distractions, if it isn't adding so much tax that it's not worth it, then it's not worth it, right? You should use what's available.
This is the whole HCI story all over again, right? I mean, back when I was writing this very efficient code for NASA, and I found out people weren't using it because it wasn't, but it's the most efficient. It's really great, but it's confusing. It's hard to use. And it's like, oh, it's that human interface is the most important piece. And
And
the
I,
hard,
I think that's super critical. Like the two things happening right now, one is letting go to be like, okay, I've written code for, well, I think since I was about 5 years old, which now is not unusual, but in the 80s was unusual. And to just let go and be like, I'm not doing that anymore it's quite shocking. But once you kind of get over that, the second is the point that Vikram and Cecilia made, which is that use the tool that works for you, right? In a way, the great thing about all these models is that they have slightly non-overlapping capabilities, and so find the thing that works best for you and the way your brain works. There's not one model that's a global maximum that you can find in this entire search space. It's going to be a function of both you and the model.
And it's a bit of a golden age we are in right now. There are like just so many things. So if you end up spending a lot of time trying to find the best tool, you'll waste a lot of time. So you,
Right.
yeah.
For like a long time, there was, a golden era, maybe 10, 15 years ago, where companies where like Ubers were being aggressively subsidized for some reason. And in the now instead of that, I get aggressive subsidization of my intense usage of these LLMs. It's a great golden era for that as well. I like not paying the true price.
Especially if you're academic. There's a lot
Yeah.
of academic credits. Okay, let's take another. So we talked a little bit about coders. So there's also AI literacy. So what are important skills that people can develop for AI literacy? And this question comes from Anna Liu, class of 2015.
I think the first thing is just to start. I mean, there are still a surprising number of people who don't use any kind of AI tool, not even chatbots. And, I think it can seem a little intimidating. I mean, just, the more you use it, the more experienced you'll become. I think all of the caveats we all talked about at the beginning in terms of reliability, keeping that front of mind, I think is really important. And then when I led the AI rollout at my last company over the summer of last year, one of the things that I would always hammer home is that it doesn't have to be complicated to be useful. And this is, I think, to a point that Cecilia and Vikram both made. It's about what you need done and really trying to kind of focus on that versus trying to build some agent right out of the gate. It doesn't need to be that to be helpful for what you're trying to do. So in terms of AI literacy, I think the first thing you can do is just start. And then the second thing you can do is really, make sure you're starting to also understand that it's not going to be reliable 100% of the time and really double checking where it matters.
Yeah,
I think that's
Yeah,
a good point. Yeah.
go ahead, Eugene.
to bounce off this a bit, like just getting started, like if you start to play with this stuff as aggressively and try to push it as far as it can go on low stakes projects where there's no downside, you will start to see the edge cases of it immediately. I think these are now such commercialized tools that there's less skill in using them than people think there is. And the skill is really in knowing at this moment, what can it do and what can it not do? And a good way
Yeah.
to get started is push it as far as it can on something where there are no consequences to getting it wrong.
Yeah.
Right.
Um,
Yeah.
Yes.
In fact, this is what I was going to say same thing, but from an individualized perspective, right? Like not in the context of your work. If it's just you playing around with it, you know, these things can, at least they promise to do so many things now that go try something. Like even if you don't believe it, right? Like go try something. Like write, write a game, build a game, right? Like, you know, do things like that you would never have done before, because it gives you a good exposure to how they work. And in the process, sometimes you might not end up with anything, but at least that also teaches you, you know, to both Eugene and Kristen's point, like what they can't do or what to watch out for. But there are more times than not, you will actually be delighted. Like you'll be like, what? I could never think of doing this. Now I can do it, right? So it's awesome.
I have to
So
jump in
I
here really quickly with a sorry, Celia, with a
go
story,
on.
which is that like everyone else during winter break, I spent my winter break playing with LLMs. And I had it write like a full social media platform with a colleague, Maria Antoniak at CU Boulder. We wrote it together. And now this is the primary social media platform that I use to interact with the internet. And like that's not something I could have possibly imagined doing before, but also now I know exactly what it can't do because there are certain bugs it will make repeatedly over and over again. And you can set yourself the goal of doing something as wacky as that, and you'll find a lot out. Sorry, Cecilia.
No, I think this is great. I agree with everything all three of you said. And I want to build, I was going to say it too, but I'm going to say one more thing that you haven't said is that I think that one of the strongest things that people should do now to is really think about the future division of labor with AI. All right. And become a deep expert in a domain, all right? Because that's something that AI still doesn't have. And I think undergrads now, what I try to teach them is prompting better isn't going to be the one you're not going to be the one who's the most useful in the future. It's the one who knows their field deeply enough to be able to collaborate with AI. And I mean, I think this is something where Caltech graduates have an advantage, you know, being trained to think from first principles. And that's the skill that AI can't yet replicate. So that's what I tell undergrads. Don't just react to the AI, but, you know, find the gaps and fill those in.
May I say something here? It might sound like I'm disagreeing with Cecilia, but I
I
want to kind of
disagree.
point out. So one way of interpreting what Cecilia said might be to say, you know, go become a specialist at something, right? Like go become a specialist at a particular domain or something like that, right? And I've wondered about that because, you know, generally my concern is that AI could, you know, if it evolves a particular way, could outpace, you know, your ability to learn about a space. And so, but and more by brute force, you know, like, but the other way I could interpret what you said, Cecilia, is you know, the ability to describe a problem correctly,
Mhm.
right? Like the ability to, you know, interrogate a problem, understand the problem, you know, think about all the edge cases, think about like sort of the nuances of the problem, how it interacts with other fields, like all of that. That I think humans are extremely well suited to do. So part of that expertise building, you know, is about whether you can get really good at being able to understand a problem space, being able to understand how to describe the problem space, because then you can use all the AI in the world to do a lot of your work, right?
Yeah.
And you get to think about even bigger problems and even more complex problems.
Yeah.
And I think that maybe that's the one nuance that I want.
That is a really great point. And I'm going to add to that too by saying that part of the problem is that we as humans don't really understand the size of the problem space. We think, oh, AI is so good at taking in a vast amount of data, so therefore it can handle any problem space. And the issue is the problem spaces now are just so much greater than even the biggest and best model can handle. I mean, and that's always been the case, right? We have problem spaces. I mean, it's a fundamental error that we humans make with computing. I still remember back in the day, the first time I saw a Cray. Do you remember the Cray that everybody talked about? This supercomputer can do everything. And I remember I got a tour of this and it was sitting there in its, cold room and the liquid cooled and it was very cool. And the guy who was demoing it said, "I want to show how fast it is." And so he said, so he took a one and he he right shifted it 100 decimal places. And then he said, and now I have it count from one to that number. And he wanted to show how fast it was. And then as it was going through, it wasn't returning. And I started calculating in my head how even if this works on, 1 nanosecond per cycle, it won't finish for, thousands of years. And, and I think that is something that we just we don't understand big numbers. What can I say?
All right,
Even,
we're going to go to our last section before we take live
okay.
Q&A, so we'll really be in the hot seat. But I think this conversation is critical because a couple of questions came from the audience about what skills should techers have when they're looking to work in AI. So it may have been, 5 years ago, you were like reading the attention is all you need and implementing transformers, and even Vikram and I did this at Caltech, probably like in MATLAB, hand coding neural networks, which of course we wouldn't do anymore. So, what advice do you have to techers looking for careers in AI?
I mean, I think you can look at careers in AI. It's a little bit funny. It's like, careers in AI. It might be that every career has a career in AI in the future. Like, I'm not sure, how long that's going to take, but I guess it's you don't have to be a machine learning specialist to have a career in AI either. I think there's a lot of room for people who are, and I guess maybe I'm speaking sort of somewhat self-servingly here as a biologist who just got interested in these tools enough to want to understand what's hype and what's not hype and really kind of go deep for myself. And I think if you're a domain expert that's not a machine learning engineer and you want to work in AI, well, that's a great thing to do is just really start to get curious because the more that you can bring that alongside your domain expertise to your colleagues who are building the models. And I think biology is particularly well suited for this because LLMs are trained on and work very, very well for human language. But biology doesn't work that way, right? So we're going to have to think about architectures that are a little bit better suited for specific biological problems. But I think that's true, generally across domains. And so the more that you can be a little bit what I like to call amphibious, and really kind of be able to work hand in hand with your colleagues who are doing the machine learning, I think that's going to be an enormous benefit for any team that you're on.
Yeah, I think everyone knows it. The value of the Caltech education is really that you basically learn that you can just slot yourself into any problem because you fundamentally develop these
Right.
problem-solving skills as well as ways of modeling the world. I think that's great advice.
Right. So I have two quick answers so I think in the next 2 years, it's going to be AI and accessibility, as I think Dan mentioned and I talked about earlier. And in 5 years, I would say human-centered AI, which is already, it's just going to get more important. So that's the area I would recommend going into.
Well, let's talk about industry academic relations, a notoriously human-centered thing that it involves large, complex systems. So, how do we see the relationship or collaboration between academia and industry changing as AI accelerates? And this question comes from Mariana Kianike.
So,
Oh, go ahead.
sorry. From the academic side, I think sort of what has happened a little bit is a little tragic. I think if we go back some number of years, there's sort of a golden era of industry academic collaboration. Industry was operating in a fairly open model. You could read, more papers were being generated, at least on the CS side, out of industry than were coming out of academia for a while. And now, at least from the AI side, in the kind of LLM race, everything has sort of shut down in some ways, and these two things are fairly closed off. So yeah, I'm not sure I have more to say than that, but there's a very marked shift in the industry academic relationship over the past couple of years, at least in the CS side. Um,
Yeah, I'd say I think this is an interesting distinction, right? So there's the CS side. When I see it, if I take off my CS hat and look at it in the life sciences side, for example, I think there is still a lot of interest and a lot of interesting collaborations that are happening. And I think that, one of the biggest issues in all of this is how the capital gets deployed, right? Like ultimately, a lot of these things are informed by where the capital is coming from and what is being prioritized for that capital. So like on the CS side, because so much money and so much capital is going into building these frontier models and being in that race for AI supremacy or whatnot, I think that is actually cutting people out, right? Like it is actually creating this environment where it is in a weird way. I don't know that there is a ton of truly step function level innovation that is being targeted.
Mm.
It's almost like they're like, we've already innovated, and now we are basically trying to be the fastest to maximize, on those principles, right? So whenever something like that happens, then there is this, there is a situation where it is not as inclusive because they feel like we know what we need to do, right? So we don't necessarily need to like, reach far and wide in order to get, insights and expertise. In biology, what's been fascinating is there's like so many questions. So there is so little we know, right? Like, and there is so much gold to be mined, and so much knowledge to be gained that some of the best people in the world, to actually be part of that journey, they're all distributed. Many of them are in academia, many of them are in biotechs, many of them are in large companies, right? Like there's all this, and the capital models that exist today in the large company context with life sciences have not really produced enough momentum, right? Like they're all designed around, maybe getting the next billion-dollar drug, or like it's a very different type of a model. So I think it's going to look different, in my opinion, based on the context that particular field finds itself in. I suspect that in life sciences, for example, there will be tremendous amount of collaboration. We might end up in a place once some things get unlocked where like a lot of capital flows in, and then like people try to raise up some walls and try to hire all the people from the academia into some walled gardens or whatnot. But I hope not. I really think that it requires a much more collaborative and well aligned model for how we do innovation.
All right, we're gonna do our rapid fire Q&A with audience questions now. So folks have submitted their questions online, and we've got about 12 minutes, and we're gonna go rapid fire. So I will ask some of the questions from the audience, and then if our panelists can give relatively short answers, we'll try to get through as many of these as we can. We had a lot of questions about hallucination. So one of our questions comes from Tashika Amirgolizadeh from PhD 2004. Do different AI platforms have varying degrees of hallucination? Which stands up above the rest, if any?
there's almost certainly a paper out there that tracks that, but I don't know which one it is. I think a quick search would return those relative rates.
Yeah, I agree. I would look at the FACT conference, FACCT conference. We'll have a bunch of papers in that space.
Just one caution though, and I think this goes back to an earlier point we talked about benchmarking. Like, be careful what is being benchmarked against, because hallucination in what domain, right? Is that will matter a lot for what kind of results are returned. So if something matters to you particularly, make sure the benchmark included that use case, or else it might not be relevant for you.
On this topic of hallucination, and when we say hallucination, what people generally mean is that it's making up an answer. So depending on the research community you're in, you might call it fabrication. But anyway, we had a question from Tad Hogg, class of 79, that says AIs rarely say they don't know answers, but instead make up very plausible but wrong answers in those cases. How can we build more trustworthy AI, especially in contexts where errors can have bad consequences, such as medicine or managing electricity grids?
Well, that's where I think this idea that Anthropic had of starting from, a code of conduct, right? And you say, we're going to prioritize safety first before you go into, you know, engagement and, certainty. So you're going to admit when you get things wrong. So I think you have to build that into your model. That's my view.
I think it would be very tough to completely eliminate them because of just some of the very fundamental architectural, elements of how these have been built, what these have been built on. So either you can do guardrails like the one that Cecilia described, or you have like some type of multi-agentic model where like there are fact-checking agents or like agents that are trying to counter check. So again a design exercise, really.
Right.
Don't rely blindly.
Right. I don't think guardrails are the way to go. I like the multi-agent way that you.
Yeah, you can also play one agent off the other. That's a common technique.
Multi-agent debate. I
Yeah.
think tool use solves some of this, right? Because if you can use a tool to get things through some other network of trust, but it's also a little bit in the objective, right? If the objective does not that you're training this thing under does not reward stating uncertainty or backing out of the answer, you're not going to get this behavior. And I think a lot of the objectives things are being trained under right now don't actually incentivize this behavior.
Totally correct. Yeah.
Super important point. Okay, potentially controversial topic. Should people still learn to code?
Yeah, because that's how you can tell if the code you get back is wrong. I mean, there's so many sort of subtle errors that I see in what Claude gives me just because I have all this experience from programming.
I
Oh, go ahead.
I would say learn to code because it makes you a better systems thinker, right?
Yeah,
Like I think you will get to maybe you will get to a place where like the code is perfect, right? Like all that aside, right? Like just knowing, right? Like how to think that way, will actually help you get the most out of any AI systems you use.
Yeah, there's this famous quote from Edgar Dijkstra, who's like a famous computer scientist from University of Texas, and he basically said like computer science or programming is to computer science like telescope is to astronomy. If I'm surely misquoting him, but the idea is that it's just a tool. The actual science part is the thinking part. Nonetheless, you still use that tool to get there. All right, we have a very practical question. Anthropic has introduced a skills template to define what you might call task paths. Most of the AI providers have adopted it. Have you used skills, or how have you used skills to organize tasks? And how can you organize this to level up your team?
So we use skills very frequently at the startup, and we have a shared repo of skills that was caused because, somebody was doing something very cool, and someone else would say like, "Wait, no, how do you do that? Give me the skill. I want to use that skill." So I think kind of finding a way to share and centralize the skills that other people are using is a faster way to let people play rather than having them all live locally. Um,
Yeah, curious to see what the trajectory of skill marketplaces and so on will look like moving forward.
Yeah, I think it's going to be, if I can weigh in on that one, I think we saw that type of thing with the prompt marketplaces. Like remember when the generative image models first came out, we had these prompt markets where you could sell your prompt for people who wanted to generate an image like you. I'm not convinced the same thing will happen with the skill market. And there was already a paper, or not a paper, but a blog post last week that basically said like skill not important, just throw it in a giant markdown file, and that actually outperformed skills. So all these things are rapidly evolving, but I also use skills. I now, like Eugene, I basically just have the model write the skill. After it does something, I'm like, hey, document what you found and save it as a skill. And that way you're just like constantly leveling up.
Right.
Yeah, but there's no magic in the skills. It's just like specifying the thing that you want done takes some work and effort, but it's when somebody specifies it for you, like
Yeah.
it's not that hard.
Yeah.
Okay, this is a topic that comes up at every event with President Rosenbaum that I've been at, which is how in our classrooms can we uphold academic rigor where we want our students to use critical thinking while also trying to integrate AI.
Well, I'm doing a research project on that next quarter, so I'll tell you my results after that.
I'll have my AI read your paper.
Please, please figure it out before she goes to university.
Okay.
On a serious note, though, for folks who are faculty, what are you seeing? Do you set AI policies in your class?
I'm trying something out now where we move a lot towards personal responsibility, and I spend a lot of time on the first day talking about how the fact, like, yes, you could cheat. I probably won't catch you until we get to an oral exam, which I also don't do. But this is a waste of your own time. Why are you even here? You don't even have to be here. You can just go um, and so my hope is that the sense of like a sense of you could get an A in this class if you cheated, but like have some personal responsibility, like try to get some joy out of this. Maybe the lack of fear of not getting a high grade anymore maybe changes the way people view the act of learning.
Yeah.
That was maybe muddled.
Yeah, how much?
I think that makes a lot of sense. I mean, so what I tell students is a version of the same thing. If you're paying a lot of money to come to the university, right? And if when you graduate, all you can do is what ChatGPT does, why would a company hire you when they can pay $20 a month to hire ChatGPT?
Yeah.
So think about what is it that you could learn that would add real value and, bring that in.
So
I'll
let's
say one other quick thing. Sorry.
Yeah.
go ahead.
We're seeing some universities start to scale up oral exams by using LLMs as oral like testers. And I don't know that I necessarily endorse that, but I think it is at least interesting and worth mentioning.
Yeah, I
Okay.
think that's dangerous because the LLMs highly rate their own. They rate their own output better than output of real humans because human speech and writing is extremely messy, whereas LLM is perfect grammar.
Mhm.
On the similar note in industry, so Kristen, how do you determine for investing what's real or what's not when you're working with a company that uses AI?
Well, I mean, in any domain, whether it's AI or not, I'm a big fan of, the proof of the pudding is in the eating. So I like to do blinded pilots with things that actually matter where you can't cheat as easily. So, my last company, it was using either proprietary data or samples that obviously wouldn't have been, part of a training set of an AI. And seeing, on something that we had maybe used a more traditional machine learning approach for, do you do any better on this task? Because at the end of the day, that's what matters, right? Is it actually giving you a better answer? Maybe random forest is the right answer. Maybe, I don't know. Like, but you show me. And then we can also talk about like, then again, in the diagnostics world, you're always talking about locking a model and then deploying it. So the compute cost isn't necessarily the key thing because you do it once, you do it well, and then you lock it and whatever it's done. But yeah, at some point you have to also weigh, okay, maybe it gives you a slightly an incrementally better answer, but does it come at a much higher cost? So that's sort of very practical, pragmatic way of looking at it.
Well, we're gonna close out with some forward thinking here, and so we had a question about what are interesting frontiers of non-LLM AI, and for folks who don't know what that means, the LLM is basically the core technology here that is a text prediction model, much like if I said, "Hey, what do you want to eat for?" then the next word is probably lunch, dinner, or breakfast. And so the LLM is just like a huge version of that. But there are other models that are not large language models. So for our panelists, what are interesting frontiers of non-LLM AIs? In 1 minute.
I was recently exposed to tabular transformer models, which I think is probably pretty cool. Like I was like, oh, that's, and I think that then it created this entire mental model, right? Some from kind of a more of a linear framework to a table, and then okay, so what else? What other kinds of data structures can you train on? How does that potentially unlock or represent different fields in different ways that might not be, sort of more of a linear chain like languages.
Hmm. Randomized data structures.
Right. All right. Well, we are out of time. So it's been a hugely enjoyable conversation for me. I love it when I hear techers get together and debate things. So thank you to everyone online for joining us. We will email a recording of the session to you so you can go back and review it and email us all the errors. I hope the rest of your evening goes well, and we look forward to seeing you at an alumni event in the future. Thank you and good night.
Thank you all.
Thank you
Thank
all.
you.